this video we're going to talk about rational exponents. And first we're going to start by looking at a little graphical example. Suppose we want to solve an equation like x to the n equals c. So that might be something like x cubed equals 27 or x to the fourth equals 16. Something like that. Depending on a couple things, the values of n, the exponent, and c, whatever number it is. There's several possibilities. If n is odd, so for example that x cubed or x to the fifth equals 51, there's always going to be one solution. If you think of this as x to the n, that function, and then y equals c, where those two intersect would be a solution. And no matter where I have my line, I could have it down here, the one line, there'd be a solution there. No matter where I move my line, there's always going to be one solution. Now if I have a situation like x to the fourth equals 20, so c is a positive number greater than 0. Well, in that case, when you have even, you're going to have two solutions. Now if you have something like x to the sixth equals 0, so it's equal to 0, then you're going to have one solution there, right there at the origin there. And finally, if you have something like x to the eighth equals negative 64, well, there's no place where this line down here intersects with the parabola or the curve up there, so there's going to be no solutions to that. So it gets a little more complicated when we have an even exponent. The reason we talk about that is because it's going to help us define what an nth root is. And so an nth root, so if we have the nth root of c, another way to write that is c to the 1 over n power. They mean the same thing. Okay? If n is odd, then the nth root of c equals the solution to x to the n equals c. If n is even, then the nth root of c is the non-negative solution to x sub x to the n equals c, if a solution exists at all. It may not exist when it's even, but those are our possibilities, and that's what an nth root is. Okay? One of the things we do, we want to do operations on roots. Some things you may have already done, some things you may not have. We're going to look at separating this out. So here, if we have something like this, what I'm going to do is I'm going to multiply the 2 times 3. Both of those are outside of the root sign, so 2 times 3. And then these two, the square root of 8 times 15, we're going to multiply them together under one square root. So 2 times 3 is 6, and 8 times 15 is 120. So you might have the square root of 120. Now that can be simplified because there is a perfect square that goes into 120. Could have done it over here with the 8, but we didn't. So 6, it's times the square root of 4 times the square root of 30. 4 times 30 is, of course, 120. And the square root of 4 is 2. So this becomes 6 times 2 is 12, square root of 30. So when we multiply inside times inside and outside times outside to get our things, and then we try to simplify at the end if possible. Now here we're subtracting, in B we're subtracting. Now we can't subtract those directly the way they are. This is like having like terms. In order for us to subtract those, they have to have the same number under the square root. So we first have to try to simplify this any way that we can. So we try to find two numbers that multiply to be 12, and one of them has to be a perfect square. Those two numbers would be 4 and 3. And the square root of 4, of course, is 2, so I have 2 square root of 3 minus. Now if I can simplify this one so it also has a square root of 3, then I can do the subtraction. because when we add and subtract, it's much like 2x minus 5x is negative 3x. If we have to, they both have x. I can't do 2x minus 5y. They both have to be x. So everything is true here. I have to have a square root of 3 here and a square root of 3 in the next position in order to do this. So think about what multiplies to be 75. Well, 25 and 3, sure enough. And the square root of 25, of course, is 5, so 5 square root of 3. And now, just like happened over here, 2 square root of 3 minus 5 square root of 3 is negative 3 square root of 3. It's just combining like terms at that point. Right. Next. You can, when you're doing this and you're going to simplify this here, we're going to simplify. That's what it's telling us to do, of course. We have a cube root. So I'm going to separate it. You don't have to do this each time, and you won't do this each time, but for now I'm going to separate it. Separate them into separate cube roots. As you get good at this, you certainly won't need to do that. We think of the cube root of 8. Well, what number times itself 3 times gives 8? Well, that number is 2. And now when we simplify the variables, we simply ask ourselves, how many x to the 6th, what's the cube root of x to the 6th? Well, the simple way is 6 divided by 3 is 2. X squared is the cube root of x to the 6th. Now, it doesn't work out quite as nicely here because 8 divided by 3 is not an even number. However, 3 does go into 8 2 times, so we're still going to have y squared with 2 left over, so it'll be the cube root of y squared. And if you want to see that the long way, we would have this. We have x to the 3rd times x to the 3rd. Okay, and over here we'd have the cube root of y to the 3rd times y to the 3rd times y squared. And what we're doing is we know that the nth root of x to the n power, no matter what n is, this is always going to equal x, because the nth root and the n on the inside are just going to cancel each other out. And so essentially that's what's happening here, is this 3 and this 3 are canceling, and that leaves me one of the two x's, and then this 3 and this 3 are canceling, leaving me the other. And that's where it comes from. But the shortcut is just to be dividing your exponents, which works just as well. Now, if we're going to do this, we're just going to FOIL. So first times first, 25 outside, so it'd be minus 5 square root of b. Inside would be plus 5 square root of b, and last would be minus b. Those cancel out because they're just like terms that cancel, and this just is 25 minus b. That's just the difference of 2 squares. Alright, so you try those, try these ones, and then come back. You can pause. Okay, so hopefully you had a chance to try these problems for yourself. Here are the answers. The first one is negative 6 square root of 35, and then 2 square root of 5 minus square root of 30. We simplified this one by pulling out a perfect square of 4. This 4 times 5 is 20, the square root of 4 is 2. But we could not do the same for the square root of 30. In fact, there's not a perfect square that goes into 30, so we can't simplify that any further than that. Okay, and then the 4th root of 16 is 2, and 4 goes into 13 3 times with 1 left over, and I should put the 4 here, and 4 goes into 8 twice, y squared. So, and then of course we FOILed here, and this cannot be simplified further because none of these are like terms. They all have different numbers underneath the radical, and they can't be simplified. Okay. So rational exponents. These are used quite a bit in calculus to take derivatives and antiderivatives of root functions. So if we have a like c to the t over k power, we can write that several ways. It's c to the 1 over k to the t power, or c to the t power to the 1 over k power. Let's fix this one here. Make that a little bit better. 1 1 over k to the t power. We can write it any way, whatever's convenient for us we can do. One big one is that c to the 1/2 power is the square root of c. Those things are equivalent, and that's a very important one that's used quite a bit. Okay. You also can go, as we said, I'm kind of hinting at it here, we can write this in radical form. Radical form just has a radical sign in it. So this would be right there. The bottom number is the root, and the top number is the power. So we write it like this: the k root of c to the t power. That is one way of writing it. The second way of writing it is to write the kth root of c and then raised all to the t power. Those things, all of these things that we've written in there are all equivalent. Okay, they're all equivalent, and we're going to learn to use the rational exponents over the next couple of days. Okay. So let's look at simplifying radical expressions without a calculator, and we're going to do that. Okay. 169 to the 1/2 power. I already told you that equals the square root of 169, which we should know is 13. And we might look at the next one, the square root of 0.0064, and say, how am I supposed to do that without my calculator? Well, you know the square root of 64, of course, is 8. When we deal with it this way, there's a quick way to do it, and there's a little fraction way to do it, and I'm going to show you both. Okay? So, first of all, if I want to rewrite this as a fraction, it would be 64 on top divided by 10,000. Okay, there's 4 spots after the decimal, so it's 10,000. 64 divided by 10,000. And we'd be taking the square root of that, which of course is the square root of 64 divided by the square root of 10,000. The square root of 64 we know is 8, and the square root of 10,000 is 100, so that's 0.08. So you can see I can get the 8 from here, and then this has 2 zeros, and so this is only going to have 1. Okay. Right, the cube root of negative 64. This is one of the cube roots we should know. First of all, it's an odd root, so then it's going to equal the negative cube root of positive 64. Anytime we have an odd root with a negative underneath, we can pull the negative out. Okay, that only works with odd roots. With even roots, you can't, but wouldn't bother with that. You end up with imaginary numbers instead. Now, the cube root of 64 is one we should know it is 4. So that whole thing reduces to negative 4. Now here, I'm going to rewrite this as a root. So the bottom is the root, so it's the cube root of 8 squared. Cube root of 8 squared. This is the bottom becomes the root, the top becomes the power. Well, the cube root of 8 is another one that we should know. A number times itself 3 times, that equals 8, and that number is 2 squared, which is then 4. So this whole thing reduces to 4. 8 to the 2/3 power is 4. And finally, the last one here, 5 to the 8th power. We want to simplify that. It's a square root. How many times does 2 go into 8? It goes in 4 times. So we just make this 5 to the 4th power. There's nothing left over to stay underneath the radical. And so that is our answer. If you want to simplify it further, it's 625. And that's what we're going to be practicing today, is this kind of simplifying.